All right. So, guys, let's start for the day. It's 12 p.m. already. Great. So, firstly, whatever we did last class, whoever is looking at programming for the very first time, are we comfortable if at all you have practiced anything at home? Any queries, any doubts, any errors you are facing? Any concept that you still feel you're not too much comfortable with or you need a little more clarity on, we can spend couple of minutes in the earlier part of the lecture discussing that. Yeah, guys, anything which have caused discomfort, please feel free to let me know. We can discuss those concepts before we move forward for the day. Yeah, Ria. So guys, we can keep a very open culture here, right? You don't need to raise hands or take permission. You can feel free to pitch it in directly. I think that's we can do that. We can go that way. Yeah, yeah, Ria. Please go ahead.
The issue I was facing, like, firstly, when I was solving the first code, that was for the mean. So, firstly, I was not getting the correct answer. Then, after that, running the same code, like doing the same code again, it was giving the correct answer. So, how can we like check that? And I don't know, right?
So you're
Yeah.
saying that you ran the same program twice and you got two different answers.
Yes, yes.
So what would have happened is that you in the initial part you might have selected only a partial code, right? So this is a very common error that you feel that you have selected the entire code, but you tend to run only a partial set of program. Otherwise, technically, if you run the exact same set of code or program in the exact same sequence, you will not get two different outputs unless we are working with something that is random. So if you want, you can maybe share your screen. We can discuss it further if there's anything. One thing what I guess is that you might have run the partial code that would have led to difference in answers or something of that form. If you want to specifically discuss some chunk of code, you can go ahead, share your screen. We can discuss that thing out first.
Yes, I can actually share my screen. I have like written the same code in two different ways, but the
Okay.
uh, like I just share my screen.
All right. Others, please keep your doubts ready if at all, obviously, we have one. Okay. Fair. Okay. Got it. Fair, fair. So, Ria, here, sorry, Ria, right? Ha, Ria, correct. So, Ria, here the error lies on line number 15. If you see, so what you have correctly done is that you have written down the mean function to calculate the average. However, mean takes in a vector or a set of observations to calculate its answer, right? So you will have to put those three observations inside a vector, right? So this is for everyone. It's a great doubt. So guys, whenever you want to supply, keep this thing very firm in mind. Whenever you want to supply more than one number, all in one go, right? Whenever you want to supply more than one number, all in one go, you will always use a vector to do that, right? So if you can just add the vector or add all these three numbers inside a vector and then run or execute the program, then I think probably that doubt what you have will be resolved. So you have added an extra bracket right in front of C. Maybe you'll have to delete that or add another extra bracket towards the end. Yeah, I think this works. Yes, that seems fine to me. Okay, comma unexpected. 23. Yeah, I think you can just remove one bracket right in front of the C, right? No, no, no. The one bracket that is towards the right of C. So let's have only one bracket. Correct. And we'll have to remove one from the back as well. Correct. Now, if you just run it out. Yeah, I think there you go. You have the answer.
Yeah, so now it's showing 16, 25, and 1. Before it was showing
That's
0.
the right answer.
So
Yeah, Kaustav, you were saying something?
yeah, as Ria has mentioned, she has defined A and given numbers after that. And later on, she has assigned X and some mean function over there. So
Correct.
can't we directly do mean
Yeah,
and
yeah, absolutely.
in A in bracket?
Absolutely, you can do that. You can just write x equals mean of a. Instead, even if you just want to write on line number 17, if you want to write a minus mean of a to the power 2, that is absolutely right and absolutely fine. In fact, if you remember, that was the exact same thing what I did towards the end of the lecture. I wrote x minus mean of x, the whole bracket to the power 2. That
Okay.
absolutely works, Kaustubh. There's nothing wrong in that. That's an absolute appropriate way of writing down the program. Good to go? Ria, I think this
Yes,
is good
sir.
to go. All
Yes.
right, great, great. Anyone, anything else? Any other question, any other doubts? Are we comfortable?
Just one thing more, like
Yeah.
this question is all right. This the formula. Do we have to remember the PDF function? Like this formula.
Sorry, come again. Do you have to?
Like this is the PDF of the normal distribution.
Correct.
So do we have to remember the
No, you
PDF?
don't have. No, no, no. You don't have to remember any formulas. You will have a table book when you sit for the exam.
Okay.
So this was just for you to, get a quick hands-on with respect to board mass rule. So that, if you are a very first time beginner writing down a program, it's a little more simpler for you to write down, type down, so that you get to gain that confidence towards the UI altogether. But you will have table books in the exam, so you don't exactly have to remember a lot of PDFs and PMFs.
Okay. Thank you.
Okay, great. All right, 3 seconds. Anyone, if you have any questions? Three, two, one. Great. All right. Good to go then. So, guys, today's agenda is simple. Last time, okay, let me put down the agendas first. So, we will continue with data structures, what we did start last time with vectors. So, we will continue with data structures today and finish indexing. If time permits, we can also start with something called as logical operators, right? Depending upon how comfortable we are with the speed. Again, you guys can let me know if you're going too slow or if you're going too fast, right? So these are the two objectives for the day. Number one, finish data structures. Number two, finish indexing. That's it, right? Some of you guys may have a question that, we are not solving a lot of questions or we are not started solving questions. So one thing what I want to say is that right now we are still at a very baby stage to solve any good level of programming question, right? Maybe after tomorrow's lecture, when we connect back next week, once we start with loops, we have good 30, 40 questions for us to solve, right? So but for now, once we are through with the lectures every day, all you have to do is to make sure that you are able to write down whatever we have learned in the lecture on your own without making errors. If at all you make an error, you're able to debug it. And secondly, you're able to understand every concept when it is being used when, right? Again, try to question everything what I say, right? Or try to question everything what we're doing, right? Why are we doing that? When should we do that? Right? That's where it enables you to think in an appropriate direction, and obviously it helps us learn beyond what is just there on the screen, right? So feel free to pitch in on any doubts or going beyond what we're talking about. I think that's where a lot of that learning will happen. Great. So guys, last class, starting with objective number one, right? I'll just quickly brief what we did last class before we move on. So last class, we started with looking at the R interface altogether. We understood that R have 4 panes. The left one is the R script, the bottom one is the console, the right one is the environment, and this is the plot section, right? You run all program in your R script and execute them and see the output in the console, right? We learned about hashtags, commenting, variable declaration, some basic properties of R, data types, basic addition, subtraction, board mass rule, all of those forms. We had a small quiz, and towards the end, you guys solved 2 questions just to get that first hands-on towards the very first program, right? That was quick and through. And later on, we understood that okay, I can no longer say 1111 information inside one particular variable name, right? For example, in a general insurance company, if I have 10 crore policy holders with me, then I cannot have 10 crore variable names sitting for each policy number, right? Similarly, I cannot have another 10 crore variable names for name of the policyholder, another 10 crore name for, its gender, for example, another 10 crore for its state, for example. So is there a way in which I can start to say multiple data points right under one structure, right? That is where the concept of data structures got into the play. And the very first structure what we discussed was vector or an array, right? If someone have learned Python, 1D array is a very popularly named called. In R, sorry, in R, it's popularly known as vector. So how do you create a vector? It's very simple. You write the C function, or I think Tom last time said, it's also can be seen as a concatenation kind of a function, which is fair in a broad sense. Or even if you want to see as a combine operator or combine function, that also makes sense because you're trying to get all of these multiple data points right under one bracket, right? Next thing what we learned was the property of homogeneity of a vector, right? So we learned that even if you give two or more data types under one bucket, R will try to convert it into a broader family altogether, right? So in this example, everything got converted into a vector of character types instead of numeric types. Are we good to go till here, everyone?
Yes, sir.
Okay, great. Thank you. So moving on next, everyone, that is nothing but the matrix. That is nothing but the matrix data type or the data structure. So matrix is nothing but a 2D array. So if you read the definition, it's nothing but like a vector only, but it's a two-dimensional array. So unlike vector, where I only move in one direction, right? It was just a horizontal thing at the moment. Here now I have two dimensions. So it's like an Excel sheet. You can also have rows at the same, sorry, you can also have rows and at the same time you also have columns, right? So great. Let us just quickly create a matrix. Pay attention, everyone. Don't type it out with me. I will give you guys time to type it out. Again, right? I cannot see your screen and face at the same time. So feel free to pitch in if you have any questions, but just pay attention of what we're discussing at the moment, because this is the first function what we'll be, ideally trying to see as to how do we write it down appropriately. All right. Great. So let's keep it simple, right? In school, we have all created a lot of matrix, right? For determinants and all of those inverses and all stuff. So let's say I want to create the matrix, what I write down on the board at the moment. So let's say it's one, sorry for the writing. It's 1, 4, let's say 1, 4, 6, 0,
So
2.
can we see your screen?
Your screen is not seen.
Oh, my screen is not shared.
No.
My bad. Okay, is it visible now, guys?
Yes, sir.
Okay, all right, great. So I was just writing down, so I was showing the script. I was saying that let's move on to the second part of the data structure, that is the script, that is the matrix. And this is nothing but the syntax or the skeleton of how do you write a matrix. So I was just saying that just pay attention, since it's our first function we're trying to write down together, just pay attention. I'll give you a couple of time to write it down on your own, right? So let's say I want to create this matrix, what we usually make it in school, a 3 cross 3 or 2 cross 2 or n cross r. All right. So obviously, as you know, it's nothing but a 3 cross 3 dimension matrix, right? So if I want to create a matrix in R, it's very simple, right? You have the matrix function in R. So the very first thing, obviously, what you do is you write down matrix. So if you see, as soon as I start to write MAT, R Studio automatically gives me a lot of pop-ups as to what exactly you're trying to write. So matrix is my function. The very first argument. So when I say argument, what you are trying to add. So if you see n row equals to, n call equals to, these are called as arguments. Sorry, is someone saying anything? Okay. So these are nothing but called as arguments within a function. What do I mean by arguments is that you require some arguments to be declared for them to work, right? What do I mean by that is if I'm creating a matrix, I will have to input some information within these arguments for matrix function to work. Otherwise it will not work, obviously, right? So the very first element or the very first argument in the matrix function is the data set, right? Now, can anyone tell me, looking at this data structure or looking at the 3x3 matrix, what is my data? How should I put all these data points into R? Because this structure is not readily available, right? I am actually writing a function to make this structure available, right? So how
Can we add
exactly
three?
do I write all the data points here? Yeah, sorry, go ahead.
Can we add three vectors like C1, 4,
Fair,
6?
great. Absolutely, that's a fair attempt. Can I start to add three vectors? So maybe one vector is 1, 4, 6. Another vector is 0, 2, and 8. And another vector is, let's say, 1, 1, 1. So great, absolutely yes. Sir, right now you just mentioned that, anytime we have to give a lot of numbers one shot to R, you always supply it in a vector, correct?
We can give three variable names beside and
Yes, you
then
can give three variable names as well. Absolutely right. But for simplicity, can I say at the end of the day, all of my data points are nothing but these 9 numbers?
yes.
Yes, right. So one very simplistic way, obviously you can give variables name, you can declare it in 3 different shapes and form. A more simplistic approach is that you can start writing all these numbers right under one bucket in a particular sequence or a format, right? So if you see 1, 4, 6, it's ideally going zigzag, right? It's moving in this direction. If you want to write it down this in this particular fashion, that is also absolutely right. You can write down the numbers in this fashion as well. I am starting with a Z direction at the moment, right? You can take another example when you are doing it on your screen, right? So it's 1, 4, 6, 0, 2, 8, and 1, 1, 1. Good to go. So again, if you see that definition, anything what you give in multiples in R always gets supplied as a vector, right? All these data points are right under one bucket. Make sense? Next is comma, and I put a enter. Even if you write anything on the same line, it doesn't matter. It's exactly the same. Just for better visibility and readability, I'm writing it on the next line. N row. So n row stands for the number of rows in your matrix. Obviously, here we have 3 number of rows in the matrix. So I'm writing n row as 3. Right? Next argument is n call. Now, do you appreciate that if I give you 9 data points and if I tell you that there are 3 rows, isn't it obvious that n call will be equal to 3? Guys,
Yes.
it's kind of, it's in very simple terms, it is like writing a plus b equals c in very, very layman terms. So I'm saying you that I have a value of C, I have value of A. Now calculate B. So it's just, kind of turning it around in that simple fashion. So you can ignore, even if you don't want to write n call, you can just simply ignore that. That's completely fine. Which makes this argument an optional argument. Right? So even if you don't want to write it down, that's absolutely fine. And the last argument is the by row argument. So what R is here actually asking you is that, how do you want me to arrange these 9 numbers? Right? Do you want me to arrange them in a zigzag manner, which means that do you want me to go row wise first, right? Or do you want me to go column wise first, right? So when I ask you this question, row wise or column wise, so if I ask you the question, do you want to go row wise, in a very human or in a very layman term, how would you answer me?
Yes.
Row wise.
Yes.
Absolutely, it's either yes or no, right? So do you remember any data type that we studied last class that actually
Yes.
talks about yes, no in terms of machine language?
1 for yes and 0 for.
Yes, fair. So it was 1 or 0. More specifically to talk about, it was nothing but the Boolean data type that we spoke about. You remember this true false? Capital T, capital F?
Yeah.
Yes?
0, 1.
Correct. Absolutely. 0, 1. So true is 1, false is 0. So R is basically asking me a question that, do you want me to arrange all these numbers sequentially by row? Since my answer is yes, and I want to communicate it to a machine or a programming language, I have to write it in terms of true and false. You can write 1 and 0, that would still work, but technically let's keep things simple by principles. You will write down true or false as a Boolean value component altogether. Make sense, everyone? As usual, let's make a habit to assign everything a variable name. Let me just indent it, and we are good to go. Everything good to go, guys, till here. How do we create a matrix?
Yes, sir.
Yes, sir.
Absolutely. Great. Let's run this one. Okay. So no errors. Everything good to go. And now if I just get to my console, write M and I print it. Is this the matrix what we wanted? 146,028,111. 146,028,111. Right. So now if you see, you have rows and columns as well, just like your Excel format altogether. Is this function making sense, everyone?
Yes.
Yep.
Yes, sir.
Great. Now in exam, if at all, let's say you don't remember the syntax, then what should we do? So let's say here, obviously I have things written, right? I have data, n row, n call. I have the entire sequence written. If at all I don't remember it in exam, then what should we do?
Is there any help button?
Yeah, absolutely right. That's good. So there are two things here, guys, what you need to remember. One, when you write the matrix function, right? If you see on my screen, automatically it tells you that the very first argument is data, n row, n call, by row, all of those different shapes and forms. Another thing is you also have something called as a help section in R, right? This is allowed in your exam. So you can search for any documentation of a particular function, right? So if I want to know more about matrix, you can just write question mark matrix, or you can just come to the search button here and start to write matrix, right? So at the moment, I'm just writing down question mark matrix. I will select the program and I execute it. Okay. Now, if you see, everything about here is about matrix, right? So you see data, n row, n call, all of the information what I exactly wrote over here is obviously copied from the head section itself. Is this making sense, everyone? However, I would not advise you to rely too much on matrix function or the help, or rather on the help section of the functionality, is because the exam what you'll be writing will be already quite a tight examination, right? If you rely too much on the help section, you won't be able to complete the paper in time. So it's better that you have so much of practice that every argument of the basic functionality is on, right on your fingertips. All right, then getting the environment back down. Is this good to go, everyone?
Yes, sir. For me, yes.
Okay, great.
Yes.
Thank you. Now, just one twist over here, guys, before I give it to you guys to practice it out. If I don't write the argument names, so someone should have asked me over here is that, sir, you wrote n row equals to, you wrote by row equals to, but you never wrote data equals to, right? You never wrote data equals to here. So similarly, if I just remove all the arguments from here because I did not write data as well. Similarly, if I, let's say, make everyone unnamed, and if I just run this set of program, what do you think? Will I still get the same matrix?
I
Yes.
think that should work.
Okay, fair. Yes. I think someone had a different opinion. Okay, fair. Let's just run and see it. If we think something is wrong or something is weird, anything of that form. Great. So exact same data set, just I have made all arguments unnamed. Now, if you see the matrix, is this what we wanted?
No.
So what did go wrong here? Exact same data, everything exactly the same. It's just that I did not write the arguments this time, which I never did it for data as well. So why is there a partiality when it comes to n row or by row for that matter?
It might interpret as n column also.
Yeah, great. Absolutely right. So guys, when you don't write any arguments over here, R assumes that you're writing it in a by default manner, what is written down inside the head section. The reason for me not writing data equals to was because that the data is the very first argument. If you write data equals to or you don't write data equals to, it doesn't matter. R understands that it's the first argument, hence it will by default assume it to be data. Now 3, if you see, next in the line is n row equals 1. So it understands, okay, 3 stands for number of rows equals to 3. That is the exact same number of rows we got here, 1, 2, and 3, right? The very next in line is n call, number of columns. I never wrote what n call stands for, or the argument. It's taking t as n call. So my n call is equals to true. And we just discussed last class, right? True stands for 1 in R. So it considers 3 rows and 1 column. So 3 rows and 1 column. See the exact same picture what we have it over here. Guys?
Yeah.
Yes.
Yeah.
Yes, sir.
Sense? So if you don't remember, or if you don't want to write down the arguments, you will have to write everything in a by default sequence what is mentioned over here in R. Right? If you don't want to follow the by default sequence, you will have to start writing down each and every argument in the most appropriate fashion. Right? Something like this.
Sir, if we are defining the data type, can we change the sequence here like you did right now?
Sorry, come again.
Like the basic structure is first sequence may we have to enter data, and
Mhm.
here you change the sequence, but you define the things right here.
Correct. Absolutely.
Like this is data, this is n row. So can
Correct.
we also do that?
Yeah, absolutely, you can do that.
Okay, okay.
That is why, that is the whole perspective of me introducing it to you guys. Before we move on to more complex function, is that you have to be ensure or very thorough with how a function is being written down at the backend. So you cannot write down anything randomly inside a function. It has to be written in a particular format. If at all you want to start writing things randomly, you will have to remember the argument names and you'll have to appropriately reference them over here as you see on my screen. Guys, is that making sense?
Yeah, sure. I had another question.
Yeah.
Like here the sequence is 1, 4, 6, and like that. If we want to change the sequence, how would we do that?
So it also depends on what matrix you want, right?
Like generally I'm not understanding why it has written 1 and 4 after that, 6 after that.
Okay, fair. So see, firstly, it is whatever matrix is something what you want to create that has to be known to you. So I have all the 9 data points right in front of me, right?
Okay.
Now, how R is structured is that you have only 2 options to write the program. Either you can go in this direction. So either you can write 146,028, 111. That is row wise. If you see, I'm filling up the rows first. I'm moving horizontally. Or you can go vertically. So 101, 421, 681. R only gives you 2 options to work with. Now you cannot write 2 first and then anything in random, because that's not the sequence what R understands or R is built to write it in that fashion.
Yeah.
Either you write it in the row fashion, that is the horizontal one, or you write it down in a vertical fashion, that is the column fashion.
Okay, so we define there like n row is 3. Let's say if we define it as 4, so it would the another value 0, it would bring 0 up there in the
Yes.
first line.
Yes, absolutely right. So it will be 1460. This would become 2. This will become 8. This will become 1. 1. 1 will be here. And then obviously you don't have 2 data points over here.
So it would be
Any
blank here.
guesses? No, it's a fair doubt. Any guesses, guys? What would R do over here? So you are now making kind of a 4 cross. Acha, but I haven't written n call here. Do you want me to write n call equals 3 as well? Or that should be left blank?
No, it has to be written now because the sequence is disturbed. Sequence thing, sorry. Like it is, or maybe it can calculate with the
It will
data points.
calculate. Even if you don't write it, it will not throw you an error. If I get it right, it will still work. So let's see how does it work. Okay, n row is 4. Acha, sorry, it was n row which was 4. It was not n call which was 4. My bad. My bad, guys. I took n row as n call. This is a new column, right? This is not a row.
Yeah.
Do
Yes.
you want me to make it n call then?
Yeah.
Or should we start with n row only? I just mixed up between n row and n call. So this is the row. That's why it has added another row if you see. So just trying to replicate the matrix what I drew over here. Right. So if you see, firstly, R has given you a warning. Right. So one thing what you have to be very careful is that anything what you see in red is not necessarily an error. It can be warning as well. What the warning is, we'll try to learn about it in a couple of minutes. Okay, so if you see, it's the same thing: 1460, 1460, 2811, 2811. Then the remaining one comes in over here. Now, if you remember, there were another 2 to 3 elements that were missing over here, right?
Yeah.
So in such a case, what R does is it goes back to the initial cells what you have declared. So it will go back, to 146. So R works in a cyclical manner. It tries to pick up every number. If it falls short of any new number, it goes back to the original sequence and start to pick. So if you see, it's 146. Again, the same sequence, 146. If let's say there was another number coming forward, it would have been 0. So it's the same story, 1460, 2811, in that fashion.
Okay, but it wouldn't be tough to identify between whether the number is repeated or not if we have a large data set.
Yeah, that's where absolutely. That's a very absolutely fair question. That's where sorry, that's where R supplies you with the warning, right? It says that whatever elements you have tried to fill in inside a matrix, it is not a sum multiple of of the total elements, which means that all the elements what you gave are being repeated more than once and not evenly. That is where the warning comes up for you to highlight that just go and check your program once, just go and check your data or your output once, because something seems to be disturbed here. So that debugging is something what you'll have to go once you see this warning sign popping up.
Okay.
Great. Guys, are we good to go on this one?
Yes, sir.
All right. So I'll make things a little complex for you, obviously. So this is an example what you have to solve using matrix for me. I'll explain you the example a bit. It's not in a very simple language to understand. Okay. So have you guys studied gamma distribution?
Yes, sir.
Yeah, you have, right? So gamma distribution has two parameters, alpha and lambda, right? Now, in R, when we learn simulation in a couple of lectures, for me to simulate, I need to have multiple values of alpha and lambda, right? It can be 1, 1, it can be 1.5, it can be any sort of combinations, right? So try to prepare a matrix of alpha and lambda, where obviously one column is alpha, one column is lambda, and you can take multiple combinations of each pair of parameters, right? The values are not given to you in the question, but then you can name it as per your own wish or choice. Now, what I want you to build on top of this is something what we've already discussed using the matrix function. What I want you to try is also give names to your column headers. For example, if you see my matrix at the moment, it is unnamed, right? It just says some square brackets, commas, 1, 2, 3, 4. I don't want 1, 2, 3, 4. So when you create a matrix for this particular problem statement, my header should clearly say that this column is alpha and this column is lambda. Obviously, you can write down the key letters. You don't want to put the mathematical of alpha notation there. You can just write down alpha and lambda in basic words. And to do that, obviously, I've written down a hint over for you guys. You have to use column names and row names. So if you want to give column names, obviously the function name is call names. If you want to give row names, that is name to these guys over here. 1, 2, and 3. You will start writing down row names, right? So how do you guys use it is something what I want to understand, given that you now are, introduced to the help section. Is that making sense, everyone? Is the question making sense? What we are expected to perform here?
Yeah, in the help there is a DIM names, so we have to define the names there.
Not exactly. So you can define it here as well, but this concept requires another concept of list. We haven't studied that yet. So you can ignore this argument for now. These two functions will be outside the matrix. So what do I mean by that is once I've created the matrix, it is on top of that I will start to use the call names and call names and the row names function.
But how will we define that this, but like if we have three columns, so what is the name of first column or the second column?
Sorry, come again. If you have three columns, then
And I have to name every one of them. So how
correct.
would I justify that this is the name for second column or this is the name for third column?
Yeah. So by default, R takes the very first name as the first column name, second name as the second column name, the third one as the third column name. So if you have three columns, you just write it down sequentially. 1, 2, 3.
Okay. Okay.
Okay. Great. So just give it a try, guys. I just want to see, if you're able to get through understanding new functions on your own using the help section. So take 2 minutes, let's say we are at 36, maybe at 38, 39, we can start discussing. Take a minute or two, see if you're able to get through. If someone wants to share their screen and volunteer, I'll be more than happy. All right, let me know if you have any questions or errors. I'll give you a couple of minutes. At 38, we can start discussing it. I'll just switch to my R screen in case you want to refer to the syntax. Okay, you have another minute. All right. Do you guys want me to discuss it or you need another minute or two to get comfort on your own screen? Guys?
Sir, some more time, some 2
Yeah.
minutes.
Okay. Okay. Fair. Fair. We can have another minute. Fair. Others, are we good to go? Or are we still solving or still trying to figure out? Everyone. Guys, a yes or no would help.
Uh, for me, it's still working.
Sorry, for you, it did work.
I'm still working, trying
Okay.
to figure out.
All right. All right. All right. Bhavani, are you good to go?
Yes, sir.
Okay. Anyone has any error in this section? So we can discuss that first.
No, I didn't have error. I just got a warning message because of the length, but yeah.
Okay, fair, fair. You can share your screen, right? We can just try to see what exactly is the reason for.
Yes, sir. I didn't change the column and row name. I just input the parameters.
That's fine. That's fine. All right. Anyone who's done with row and row name, so not row names exactly. Anyone who's done with column names?
Sir, I put the command column names, but how to add it, I don't get because there is a round bracket. So I should add it one by one. Means first alpha comma beta.
Yes, absolutely. You will supply it as alpha comma beta. Absolutely, yes.
Okay.
Yeah, Bhavani, waiting for you. Anushka, or you can also go ahead and share your screen. Asha, okay, I'm sorry. Thanks, Bhavani.
So, yes,
Okay,
sir.
fair. So I think the warning error is gone, right? I don't see any warning on your screen.
Yeah, I just added the thing.
Fair, correct. Great. So that's good. Uh, I just hope you appreciate lambda cannot be zero.
Yes, sir. Yeah. I just gave some random values.
Yeah, okay, yeah. So this is also just for me to evaluate, how cautiously, taking the statistical, element. That's fine. Okay, so how would you give row column names, right? So at the moment, I can just see is comma, some square brackets 1 and 2, right? So how do you think we would work on with column names? Okay, fair. Writing on the function. Great. Step 1. Correct. So on what data structure you want to apply the column names? On C? Yes, absolutely
Yes,
right.
sir.
So it will be C. Correct. Then you apply the assignment operator. Correct. So you're supplying two names together. Again, alpha and lambda. More than one. So I'll have to use vector. Right. Remember the golden rule we discussed right at the beginning of the lecture. Whenever you want to supply more than two elements at once, you supply it in a vector. Great. Absolutely right. You can just control enter and then execute C. Yeah. So if you see now, instead of having 1 and 2 simply, you have the names what you have declared over here.
Yes, sir.
Is that making sense, everyone? Are we good to go with this part? Are we comfortable with this part, everyone?
So actually, I was doing the same thing, but inside the matrix function. So I was getting an error.
Yeah, you can do that. So when you use dim names, right, it requires a function called as the list function, right?
Okay.
Since matrix is a two-dimensional array, I hope you appreciate that. So when you just write names, R gets confused that are you talking about rows or are you talking about columns? Since this function specifically says call names, R is not confused as to what are you talking about. It understands you're talking about rows or columns straight away. So maybe today when we see the list function, we can go ahead and also start to apply that dim names argument directly instead of working on with call names and row names. Good to go?
Yes.
Great.
Yes.
Everyone else, guys, are we through with this one? Especially someone who's seeing programming for the very first time. Are we comfortable with this? How do you write down a function? How do you build a matrix?
Yes, sir.
Great. All right. Thanks, Bhavani. I'll get my screen back up here. Okay, screen share. Great. Can we pull up a little fast now, everyone? Does that work for us? Or the pace was just fine? Or is going fine?
It's fine, sir.
It's fine. All right, great. So now can anyone tell me a quick disadvantage of writing a matrix or building a matrix or of the matrix data structure? So if you see, we started with variable creation. Only one single variable, one single element, too much of a hassle. So we came to vector. Vector was only 1D, so we came to matrix 2D. Now obviously you can go 3D, 4D, 5D, 6D, but anything specific that you think a matrix lacks, that needs to be fixed now. So the answer is in this definition, if you remember it.
Data, sir, I think data type would be same for matrix.
Yes, absolutely right. If you read the definition, it says matrix have similar properties like vector, which means that matrix is also a homogeneous data structure. By homogeneous, I mean that it can only take one single data type. So in an insurance company, right, my one column can be policyholder name, one can be policy inception date, right? Another can be, endorsement flag, that is true or false. Next column can be premium, right? So it's a combination of numeric, boolean, dates, character, all of this different mix, right? Which obviously, as you guys correctly mentioned, matrix cannot handle because of its homogeneous structure, right? This is where we move on next to the third part, that is the data frame, correct? A data frame can basically have multiple columns with multiple data types, which means that obviously one column can be of only one single data type, right? Let me demonstrate you guys, or let me display you guys to you guys data frame. So if you see my R script, I have written something called as a view function. Why do you say it's a view function? Because obviously it's a parenthesis associated with a keyword. V is capital, pay attention. Usually students miss out on that. Now, have I defined iris anywhere, guys? Do you know what iris is? Someone who's doing programming for the very first time, looking at programming for the very first time. Do you know what iris is? Or
No, sir.
do you remember? Yeah, absolutely not, right? So again, if I just write RII, you see R is giving you two data sets. So R also have multiple data sets inbuilt on its own. Iris is just one of them. So if you see, it gives a definition. The famous iris data set gives measurement in terms of, it's basically you have a lot of flowers and then the measurements of petal length, sepal length, all of those forms. So when I say view iris, R will open up a window for me where it will help you visualize the data structure in kind of an Excel kind of a format, right? Now, obviously, do you appreciate Setosa? Obviously, by the very nature, cannot be numeric, right? It's a character element. So character elements sticking towards the left side of the vector or of the side, and all numbers residing towards the right side. The alignment is towards the right side, right? Everyone? So this is nothing but a data frame, right? A data frame can have multiple columns, where one column can be a date format, one column can be a numeric format, one column can be a Boolean format. All of these different structures, all of these different data types and form right under one structure now. Is that making sense, everyone?
Yes.
Good to go. So how do you create a data frame? I'll just quickly also help you with the syntax here. Or before that, if I were to ask you as a question, how are you so confident that this is character only? Or for that matter, how are you so confident that this is number only? Obviously, one way I helped you guys identify is that the alignment is towards the right side. Ignoring that the alignment is on the right side for now. If I were to guys ask you guys again, how are you confident that this is nothing but a numeric input and not a character input? Right? So, because initially we have learned, right? We have quotes inside every character elements, which we don't see here as well inside Zetosa. And obviously you don't see inside point 2 as well. So how would you exactly identify or appreciate or understand what is the data type of petal width or sepal length for that matter?
There may be a function which we use and give a reference of this, and that will return the value whether which form of data it is.
Yes, absolutely right. So guys, we have a function called as str. So you can think of this function to be a structure, right? It basically tells you the structure of the data, what you give it to. Since my data frame over here is iris, it will give you an entire quick snapshot of the structure of the data frame. So if you see the output, it says data frame, 150 observations, that is 150 rows, 5 variables, which means 5 columns. This data frame has 4 variables or 4 columns. All the names are given to you here. And their data type is also given to you here. So it's num, 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 num. You also have something called as a factor as a data type. We learned this in unit 4 when we start with regression and GLMs. For now, you can ignore it. For now, you can just think of factor as nothing but a closer version of character or string altogether. Make sense? So if you want to appreciate, right, if you want to understand what exactly is the data structure looking like, so at times in reality, you get a lot of unclean data set, right? A numeric premium field might be converted into a text and given to you, right? So it's important for us to understand and appropriately clean the data before we put it for any actual analysis. Great. Are we good to go till here, everyone?
Yes, sir.
Great. How do you create a data frame? I'll just quickly demonstrate you that. Right. So let's say I want to create a variable name M.
Sir, I had a doubt.
Yeah, Bhavani, go ahead.
Sir, str is string or something else?
It's structure, it's not string. So
Okay.
str kind of is giving you the structure of the data frame, what you input inside it.
Okay. Sir.
Okay, so if you write str,
Function called
the
class.
instruction. Sorry, come again.
Is there any function called class so that we can check the whether it
Yeah,
is
you have that as well. I don't know how many of you guys noticed when I was teaching you guys lecture 1. If you see the script, you already had this function over here. So class function gives you the data type of that particular element altogether. So when I write class M, what was M, guys? Do you remember?
Matrix.
Matrix, absolutely yes. So it will give me the data type of the matrix. Okay, sorry, no. Okay, here it's giving me a matrix array. But if I give something like this, for example, then it gives me numeric. So whether it's numeric or it is factor, class gives it to you if you don't give us a structure altogether. So the class function works only on a vector, right? Is this making sense, everyone?
Yes.
Is it like that class function only works with specific, let's say cell? I don't know what we call it R. Let's say a particular cell. If we take example of Excel,
Yeah. So here you
and
can see that I have selected an entire column instead of one particular cell. The class function works with a particular row or a column altogether. It need not be a particular cell. Obviously, if you can work with multiple data points, a single data point is also applicable anyways.
okay.
Right? Any doubts, anyone? What I've written down over here?
Yes, sir. When we were asking the class of M, we
Mhm.
should have got matrix, but we got as matrix array. Why is that so?
Correct. Because you gave it a structure, right? So M is a matrix, it's a data structure. Similarly, if you start writing down class M, for example, class iris, for example, if you see it gives you data frame. So basically you gave it a data structure instead of some data points. Now, what do I mean by that is when I gave class iris, R took all of this entire data set to classify it as what data type it is. But ideally, if you see, it's not a data type altogether, it's a structure altogether. So it's giving you the structure type, whether it's a data frame or it's a matrix or an array. Right? When I write it in this format, if you see on my screen, the one what I'm highlighting, this means that, or the dollar symbol here means that I'm saying go to the iris data set. Dollar means go inside iris. So when I write iris dollar, you see this pop-up coming up. This pop-up is basically asking you what column you want me to select. Now here I specifically selected sepal length. Now R has a little more finer version of the understanding that, okay, if this is my column, then this is the vector I'm talking about. Hence, being more specific, it understands that, okay, this is numeric, this is character or factor or whatever it is altogether. So you are now narrowing down instead of giving a broad structure where it is returning you back the structure altogether. So you will have to go a level down to tell R that, okay, this is specific column I'm talking about.
Yes, sir. Got it.
Great. Everyone good to go with this one?
Yes, sir.
All right. So I'll just quickly help you understand how to create a data frame. So again, data frame is the function name. Let's say I just want to create the same insurance policy setup. So policy number can be my column name. And let's say I want to declare 10 policy numbers from 1 to 10. Now, how should I write it? Should I write it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? That would be too tedious, right? We are working with programming, you remember? There has to be some efficient way. So any random guesses? How should I write a sequence from 1 to 10 at a step of 1? Any methods or any functions, you doesn't matter, right? Even if I have studied or not. What do you think intuitively it should be called?
Range.
Range. Great, absolutely fair. Range makes more sense because I'm giving the lower bound and the upper bound, and I'm trying to cover all particular data points within that particular range. Great, good thinking. Anyone else? Chalo, great,
One double
good.
dot then.
Sorry.
One, then double dot, and then we can have 10.
Okay, fair. Actually, I did not exactly understand what did you mention. Can you please repeat?
Like writing one, then after that we write double dot, and then we could have 10.
Correct. Fair. I think this is what you're trying to tell, right? Or communicate. It's
Yeah.
1:10.
Yes,
Correct.
Yes.
Great. Absolutely right. So whenever you want to create a sequence, guys, you can write it in this format. So when I write 1, it means starting from 1, colon, 10 means starting from 1, ending at 10 at a jump of 111. So when I only write 1:10 in my console and I run that much, you see I have an entire series of numbers being generated here. 1, 2, 3, so on up to 10. Make sense, everyone? Good to go? Any questions here?
No, sir.
Okay. If you don't have any questions, guys, then we have to think more of what we are studying.
So
What type of data is that policy number which we have written?
It's numeric because you have declared a numeric input here, right?
So the policy dot number is a variable which we have
Yes,
declared.
it is. Yes, absolutely right. It's a variable. Instead, it's a column name of the data frame M. So just like here in Iris, you had sepal length, sepal width. In my data frame named M, I have a column named policy.no.
Okay, so it is by default treated as column name.
Yes, it is by default considered as the column name. Absolutely, yes.
Okay.
sir, I had a doubt. Now we are like we need like a step count as 1, but what if I want 1.5 and so on?
Fair. That's a fair doubt. You should have that doubt once you see this thing. So for that, everyone, if I want a sequence of not a fixed integer 1, if I want it to be of a varied length, you have a function called as seqnr, right? Standing for sequence. It's a very simple function. Where do you want to start your sequence? Let's say 1. Where do you want to end your sequence? Let's say hypothetically 5. And what is the exact jump that you want to take? So let's say 0.5, it can be 0.25, it can be 0.1, it can be 0.75. That jump can be anything what you decide, right? I'm just keeping it 0.5 to keep it simple and crisp for now. Great. So if you see the sequence, starting from 1, ending at 5, at a jump of 0.5, 0.5, 0.5, 0.5, 0.5. Everyone good to go?
Yes.
Yes, sir.
Great. Let me also add just one column. I'll just randomly add. Let's say I add premium. Right. And let's say I just randomly generate 10 numbers of premium 1000. For example, I'm just doing it randomly, guys. Don't pay attention to what I'm writing down. Great. So no errors. If you go back to my environment and if you see, I have this play button towards M, highlighting that this is nothing but a data frame. If I get my cursor over here and if I just right click or left click on it, again, you will see that Excel type setup coming up in. So as we discussed, policy number is the column name, premium is the second column name, and you have all that structured data right sitting up over here. Is that making sense, everyone? Is data frames clear?
Yes.
Okay, great. So I won't give you time to write this down because it's a very baby thing. Rather we'll move on forward and try to take some or spend times on questions which are a little more complex or difficult to work with. Are we clear? So for now, what we should appreciate and understand is how the three data structures differ: vector, matrix, and a data frame. Are we clear with that, everyone? Yes, no?
Yeah.
Yes, sir.
Yeah, great. Before we take a quick 10 minutes break, can we just finish with list before we take a break? Or we take a quick 10 minutes break? I think it was till 12:50, right? We had a 10 minutes break in between. So can we
We
just
can
finish this and take
continue
a break?
this
Yeah.
and break after that.
Sorry.
We can continue with this and break after we complete this.
Yeah, fair. Great. Thank you. All right. So before I start with the last structure, any one of you, would you like to now take a guess what would be the next step in the data structure? Again, connecting the dots. We started with one variable name, too complex. 1D array. Again, very simplistic. 2D array. Even in 2D array matrix, I want multiple data types sitting inside one data frame, that is data frame coming together. Now what next?
Sir, maybe combining all of these things like a vector also in that matrix also in a single structure, or let's say data frame in also that particular structure only.
Fair. Great. So, were the other team members or were the other classmates able to understand what, I think one of our friend was trying to tell?
Not really.
Okay, fair. Not really. Okay, great. All right. No worries. Let's just try to first, try to understand list, and then maybe I'll just show it to you. So, guys, now if you see, we almost cracked all disadvantages of one or the other data structures, and we have arrived at data frame, right? Now the question is, what if I have 5 data frames, or what if I have 100 data frames, right? Here, when I created a particular single data frame, I had one variable. Now, Tanish, if you have 100 variables, or if you have 100 data frames, can I say I will have 100 different variable names? Data frame 1, data frame 2, data frame 3, data frame 100. Are we able to connect up to here, everyone?
Yes, sir.
Yes.
Yeah. Now, can I say it's
Yes, sir.
again we are looping into the same problem now? Sir, when you started with one variable name, you said I cannot have 100 variable names. That's where we moved on to vector, where we were like, okay, at least I have multiple data points under one structure. Now, for two-dimensional, we went with matrix. For multi-data types, we went ahead with data frame. Now, the question is again, for one single data frame also, you still require that one variable name, right? If I have 100 or thousands of variables or data frames, I will require thousands of data frames as well, or thousands of variable names as well. Are we getting back into that same loop if you are able to connect it well?
Yeah.
Right? This is where list comes in the game, and list says that, okay, now if you want to save any data structure within me, now this is a very key important point, right, everyone? That's if you see, it's written in caps here. It is no longer data points, it is data structures. What do I mean by that is, I am no longer adding data points inside a data frame altogether. Now I'm working with the structure itself, which means that list is kind of a bag that can hold a data frame or multiple data frames, or a vector or a matrix or a single variable name. So whatever data structures we learned, a list is that structure that can hold everyone else inside it, right? I'll just show you one example over here for you to appreciate better. So for me to create a list,
Sir,
sorry, go ahead.
before you go to the exam, can you explain that again?
Can I explain the concept of list again?
Yes, sir.
Yeah, sure. Let me just show it to you a little visual way. That might be better. So if you remember, we learned 3 types of structures till now. One is we learned vector, one is we learned matrix, and the third one was data frame. Right? Now, what if you have 5 matrix and you have 100 data frames? So ideally till now, whatever we have learned, can I say you will require 105 new variable names to be catered to?
Yes, sir.
Right? Can I say it becomes too complex again? We are getting into the same loop. See, appreciate the whole objective of moving away from a one single data point was, if I have 1 million data points, I don't want to have 1 million data variable names. That is where data structures got into the play. Now, again, if you try to loop me in the same game, that 105 data sets, that means 105 variable names. I want to avoid that again. I don't want multiple variable name, because then I have to call multiple variables. Working with a lot of variable name becomes too complex. That is where list comes into the game. List is again a data structure only. What list says is that I am that structure. Please don't mind me for my drawing. I am that structure within which you can save a vector, you can also save a matrix, you can also save a data frame. So even if you have 100 data frames and you have 5 matrix and 1 vector, all of this 106 data structures can lie inside this one list, which have only one single name. Let's say M for now. So again, I don't have to refer to 100 other variable names. M is the only guy or the variable name I have to refer to when I'm talking about even such a huge quantum of data sets. Is that giving you a better clarity?
Yes, sir. Yes, sir. Thank you.
Right? Now, one thing what you should appreciate is that again, a data frame can have 100 rows of its own and 100 column of its own. A vector can have 533 values of its own. It can have all those possible combinations. That is not important. The whole important concept is that you can save everything else right under one structure. Whew. Great. Can we start with doing it in R programming, everyone?
Yes, sure.
Great. So the function is very simple. You write down list and you just keep supplying whatever elements you want to supply. So let's say I already have M as a data frame. Let me also make V as a vector, let's say randomly generating any specific data points, right? And let me also have a matrix, let's say that is M80RAX, right? Again, randomly just doing it out stuff. 1:6, that is 6 data points. Let's make N call as 3, 3:2 matrix, 3 columns, 2, 2 cross 3. Great. Now let me just feed everything into a variable name L. List. Let's say I want to give the vector first. I want to give the matrix as second. And I want to give my M, that is my data frame at last. Let me just run this one. Okay, it says V not found. I never executed this very first line. That's why it says error, V not found. Okay, good to go. No errors. Now, if you see my environment, right? For matrix, you had clear definition. 10 rows, 2 columns. For L, it clearly says list of 3. Now, if I just click on this play button, see it says that the very first data in your L is a vector. The second one is a matrix. And the third one is a data frame. See, it's written over here, right? So if I just run L, see, in one slot, it has just held one vector what I made. In the second slot, you see it's written 1, that's the first slot. 2, that's the second slot. 3, that's the third slot. The exact same structure what we created, right? So I don't need to have multiple different variable names for different data structures. I can just have all of these guys right inside one single variable name, that is L. Is this making sense, everyone? So it's like kind of you're having multiple sockets, and inside each socket, there's a different data structure that has been sitting. It can be all data frame, it can be vector, combination of matrix, any combination what you want to make it and try it out. Is this clear, everyone? All of us?
Yes.
Yes, sir.
Great.
Can you show the code again? Just
Yeah,
there's
I'll
little
show
small
the syntax
yeah,
again. This is the syntax. If you want to see my script, this is the script.
Sir,
To go?
in a
Yeah, sorry.
in our given in our given list, we have only three variables: V matrix and M, means vector matrix and data type.
Correct.
In real life, if we have hundred or thousands of variables in a list, and I want only one particular, for example, matrix from the list, so how can we get?
Great. Whoever was it, she has an absolute great doubt. This exact same thing is what we'll be learning next in terms of indexing. So just hold on to your doubt. You have a very fair, you are moving in the very right direction. So if I have hundreds, how do I exactly extract some particular element? That is where the concept of indexing comes into the play. What we will discuss today before closing for the day. So just hold on, for a couple of minutes, before we do that. So long answer short, the answer to that is indexing, and we will learn indexing obviously, after the break.
Okay, sir.
Is that making sense?
Yes.
Okay, great. Everyone, are we clear with this structure? Any doubts?
what is M? I didn't get that M actually.
M is nothing but a data frame. If you remember, I created a data frame or a dummy data frame here.
Okay.
Remember this code. So I never wrote it again over here because it's already created in my environment. Doesn't make sense to write it down again and run it. Hence, it was never declared over here.
Okay.
Yeah. Great. If you guys don't have any question, I have a question to you guys then. So I understand vector, where it is being used. I understand matrix. I understand data frame. Where exactly do you think a list would be used? In what application do you think a list would be used? So data frame, it makes sense. Be it any practical data set, right? It always consists information in terms of character, Boolean values, dates, numbers, all of those shapes and forms. So data frame is clearly, what we breathe in day in, day out, right? We can clearly appreciate and understand that information. Vector matrix, again, we're just trying to build things more complex. So again, that is absolutely what we can, appreciate why they are being made. But can anyone tell me what application you would have with respect to list? Because this clearly doesn't seem intuitive, trying to combine a lot of data structures into one game. Obviously, one application I mentioned, right? It's just trying to save a lot of different variable names. So if I have 1,000 data frames, I don't want to have 1,000 data frames, hence list. But that is again not an application, right? That is not a problem statement where I would use a list. So any one of you would like to add any applications where you think list can be used, or any applications where you have already worked with list? See, any random guess is fine. No issues with that. Even if you're wrong, that's absolutely fine. Nothing wrong with that.
We may not able to use for the final, to get the final outcome, but for a data cleaning activity, so it will be useful.
Okay, for data cleaning activity. Okay, can you elaborate a little more when you say data cleaning?
Let's say like combining multiple data set. That's what I was referring to. Let's say I have
Appending kind of.
Yes.
Fair,
So let's say I have multiple years data. I want to combine all together in order to generate a report or whatever. So I can use it.
Fair enough. Dealing with large data. So Kostub, if the data is large enough, then I can just save it inside one data frame name. That's absolutely fine. So if I have a data frame which has 10 crore rows and 130 columns, I can just save it inside one single data frame and give it a variable name. That's absolutely fine. That works absolutely fine with us. Great. I'll just quickly help you guys with that answer, or one application where I worked, right? And then we obviously run for the break. So one application where I worked in my master's program with list is this application, what I will tell you now. So one of my mentors, she was pursuing her PhD from IIT Bombay, and she was trying to estimate parameters using Bootstrap. Right? You guys may not have something of Bootstrap, but have you heard or do you know what all methods exist to estimate a population parameter? What all methods you have studied?
Method of moments and ML.
Method of moments, then MLE, right? Anything else? One more method remains.
GLM.
Sorry?
Confidence interval, but confidence.
Confidence
GLM.
interval is not a method of estimation.
It,
Sorry, someone is saying something with G.
no.
GLM.
No, GLM is not exactly a parameter estimation method. You estimate parameters in GLM using MLE, obviously. Okay. OLS you might have studied. Ordinary least square estimates. Inside regression. Right? Anyways, if you don't remember, not a problem. So, so for example, if you say you have X follows normal with parameter mu and sigma, right? I just need information of X to estimate these two parameters. Similar to that, you also have a bivariate normal distribution where you are saying X comma Y combined, let's say, follows obviously a bivariate normal distribution with some set of parameters, right? Similarly, for us, our distribution had 6 random variables, right? That was X1, X2, so on and so forth up to X6, for example, right? And we were using a method of bootstrap. Now, when I say method of bootstrap means, in very simple terms, it means you will calculate the number of estimates, right? So in MOM, let's say you only have one set of mu sigma or you only have one set of lambda. In Bootstrap, you have multiple sets of parameter values. It's not just one single unique combination. So can I say if I change my data set, automatically my estimates would change? So this one would be a little more of, let's say, beta I hat or beta 1 hat, one set of estimates, second set of estimates, third set of estimates. Guys, are you able to understand?
Yes, sir.
Yes.
Others, it's okay if you feel it's going heavy. I will try to further simplify it. Are we sure we understand this? What I'm trying to tell over here?
Means you are taking the different samples and making the estimate, right?
Yes,
But
absolutely.
population is one.
Yes,
From
absolutely.
one. Yes.
Absolutely on point. My population is just one single bucket. From that, I am taking multiple samples. One set of sample is, let's say, all of these 6 random variates with, let's say, 100 rows. That is sample number 1. Similarly, I go towards the population, take another sample. This is sample number 2. Sample number 3, sample number 4. I can do it n number of times. Now for each sample, can I say I will have one set of estimates? So this is estimate number 1, estimate number 2, estimate number 3, right? So if you see here, each of this structure is nothing but a data frame, right? Don't get confused. X1, X2, X6 are my columns and here are my rows. So every data frame is having n number of rows and columns, right? Now, Bootstrap, or rather in Bootstrap, the number of beta I is what you calculate is usually, let's say, somewhere about 10,000, for example. Now, I hope you appreciate 10,000 betas means 10,000 data frames, right? I cannot have 10,000 different variable names to work with each of these Bootstrap estimates. I need a structure that can hold everything inside one bag altogether. This is where list comes into the play, right? So if you want to apply a bootstrap concept, what is bootstrap? You haven't studied. For very simplicity, think of it like you are estimating multiple parameters. Just like here. One data set, one parameter. Second data set, second parameter. Third data set, third parameter. Right? So I'm just creating multiple data sets, multiple estimates. That's nothing but a broad concept of bootstrap for now. And for that, I hope you appreciate this entire structure would require you a list for us to process. Otherwise, it's almost impossible for me to work with 10,000 different variable names or 10,000 different list names or data frame names for that matter. guys?
Sir,
Is
so here the x1 to 6, the samples are different for different parameters. Like we are not taking the same sample for the
yes,
26.
yes, you're absolutely right.
Different.
So for example, if I just want to make it a little more obvious, this is how your data set would look like. All numbers are different, right? But again, they come from the exact same population. So if I assume that my population is a multivariate normal distribution, all of these data points come from the same population, but obviously it's a random sample, right? Hence, all the observation tends to be different, where obviously each one of them is a data frame on its own. Is that making sense? Is this going too heavy? Is it going in the direction where we are not able to understand? Please feel free to let me know.
Yes,
It's
it's
clear.
fine.
Okay, great. So obviously this activity, what I mentioned, right? We will also do this one activity. What I did, we will do a demo of that one once we reach loops, once we reach Bootstrap. So just park this, application for a couple of weeks, maybe before we reach to that point. All right, then I think time for a quick break. If you don't have any questions, are we confident till here, everyone? Okay, great.
Yes.
Yeah.
All right,
Can
great.
we-
Thank you, everyone. So let's take
Yeah.
a quick break. I think we have a 10-minute break. Let's connect back at 31 or 32, whatever is comfortable. Let's start back at 31, let's say 31, 32. I think we have lecture till 150, right?
140.
140. No, it should be
140.
150, right?
140.
140.
47.
So let me just continue.
It's 140. So is there a break in between of 10 minutes? Because it's a 50 minutes two
There is no,
lectures.
there is no break actually.
Achha, there is no break. Then okay, then
Yeah.
it's on you. Do you guys need a break? Then I assume there was a break in between. Okay.
I mean, it's only another 15 minutes now. We'll continue. It's better.
Okay. Everyone comfortable? Or do you just need a quick 2 to 3 minutes refresher before we get back? Okay, don't worry. It's okay. I won't text it. We'll switch it to
2 to 3 minutes.
140. Okay, fair. Let's get back at 23, 25, 26 then. So we can have a quick 2 minutes break, 2 to 3 minutes refresher. We'll get back at 36. No, sorry, 26.
Can you share that code?
Which
the
code?
data frames yum.
This
Yes.
one?
Yes.
Yeah. Yeah, it's on the screen if you want to write down. So just for clarification, if you are confused, what does this NR norm means? So norm stands for normal distribution. R stands for random sample from normal distribution.
Okay.
Right. So R stands for random sample from normal distribution. How many data points do I want? I want a random sample of size 10. Hence 10. And normal distribution have two parameters, mu and sigma. So that is what I've written here, mu and sigma, 10,000 and 50.
So previously we also used a function called as denorm.
Denorm, yes.
What is that?
So in R, D in this context stands for densities. Now densities of which distribution? T, F, chi-square, gamma. It's normal in that case. Hence denorm. Right. So if you remember, densities takes in three things to calculate. To calculate densities, you require three things. F of x. So the very first element is that you require an x value. So let's say x is 1, for example, hypothetically. And obviously, since it's a normal distribution, you will require the parameters mu comma sigma. So let's say it is 0 comma 1 for now. Right. So this is nothing but the exact f of x, what you used to calculate in your books, 1 upon square root of 2 pi sigma square. Obviously, it's a standard normal variate. So
That's a small x, right?
sorry, come again.
It's the PDF, no? D no.
This is yes. When you say D stands for densities here in that case. Hence, it's the PDF or f of x.
Fine. Okay.
Okay, great.
Sir,
So in the
can
given
we
example,
again go to the Excel sheet?
Sorry, come again. Can I show the Excel sheet? Is that what you asked for?
Sir, what I understand here,
Hmm.
first these are samples from
Correct.
the same population, and 1, 2, 3, 4 are the sample numbers. Is
Yes.
that right? Oh,
Yes. Broadly, yes. You got it right. Yes.
oh, that's I'm thinking.
So it's very okay. I'll simplify it for you. When I say X follows normal, can I say I only have one random variable?
Yes.
Yes, absolutely right. So when I say I have a one random variable and I collect 4 sample data points or 4 data points from it, can I say it looks something like this?
Yes.
If you remember your if you remember your notebooks correctly, then it would be x1, x2, x3, x4.
Uh,
Let x1, x2, x3, x4 be a random sample from normal population with mean, mu, variance, sigma, square.
yes. Yes.
Right. Now, instead of just collecting data points one way, this was a univariate dimension, hence only one direction. When I go to multivariate normal, for example, I can have more than one exercise. Hence, I can keep on adding dimensions now. So it is coming from a multivariate dimension. It's no longer a univariate or a single axis dimension now. Right? So two
Okay.
variables,
Okay.
it's a two-dimensional thing, right?
Yes.
So whenever you plot a scatter plot, you require x and y pairs. Now if I go to 3D, I require x, y, and z. So x, y, and z. This is a 6-dimensional game. Obviously, you cannot visualize it, but it's a 6-dimensional data point now. So this one data point is actually sitting somewhere in that 6 multi-axis dimension.
Oh.
I hope that doesn't confuse you further.
So whatever we learned in the sampling distribution and the sampling inference part, it is a multivariate thing, or it is a univariate thing.
This grid, what you see here, okay,
Ah.
in your sampling, you have learned everything that is univariate.
Okay.
In your syllabus, or as far as actuarial science is concerned, you don't have anything called as bivariate normal, as far as I remember the syllabus correctly. Or at least I have never gone through bivariate normal in the material of CS1. Right? So whatever we have learned, CS1 and CS2 broadly, it's all univariate. It's not multivariate or bivariate for that matter.
Okay.
Joint distributions, what you have studied, if you remember in CS1, x comma y, that grid of n cross r, for example, that is definitely a multivariate one. But then that distributions are not towards normality or specified or generic distributions. They are more of tabular distributions for that matter.
Yes.
I hope I'm not confusing you guys. Feel free to pitch
Yeah,
if
it's
that's happening.
fine.
Yeah, I hope that was not confusing, right? So
No,
joint
no.
distributions, you remember, right? You have a XY grid and then you have probability sitting right between that.
Yes, I remember.
Yeah, correct. So that is more of a tabular distribution, unlike let's say f of x, where I have a complete mathematical formula written. 1 upon square root of 2 pi sigma square, all of those different forms. Good to go, everyone?
Yes.
Okay, can we start, every guys?
Yes, sir.
Okay. I think someone had that question. So let's quickly finish. We'll close at 1:40, don't worry. Okay. Now, guys, the next question, as soon as you finish data structures, should be that, now you have a universe of data points, right? Initially, I had only one data points, had no issues. You call the name, you're good to go. Now, in the world of billions of data points, how exactly do I understand, or how exactly do I extract, if I want to extract this particular service data frame, right? So that is what this question will be trying to answer now via the concept of indexing. I think someone would also, I think it was Bhavani, I'm not sure. I think similar doubt, right? How exactly do I extract in all of these billions of data points? The answer to that is indexing. Now, in very simple terms, guys, indexing is nothing but, think of it like an address, right? All of us, wherever we reside, we have a specific address for the government or for the passport to reach, right? Or for any Amazon parcel for that matter. Similar to that, every data point what resides here has a location where it resides, right? Now in R, since we have pin codes, right? 4000, 71, 78, all of those different numbers form. In R, those locations or those pin codes, let's say starts from 1, right? So sequentially, whoever is sitting at the very first position is residing at number 1. Second position residing at number 2, number 3, number 4, so on and so forth. This is nothing but indexes what have been allocated to each of the cells sitting over here.
Here,
If
if you
at
are
all,
explaining something, screen, you are not sharing your screen.
sorry, come again.
I said if you are trying to explain something on your screen, you are not sharing your screen.
My screen is shared, right, guys? At least I can see it is being shared on my screen at least.
Yes, it is visible.
Yes,
It
sir.
is visible.
Okay,
Okay,
let me
fair.
just read.
Can you just
So,
try to log in once again? Yeah, okay, he's gone. All right. Okay, maybe we can just wait 5 seconds for our friends. 5, 4, 3, 2, 1, and we're good to go. Okay, fair. Let's start. Okay, great. He's here. All right. So similarly, let's say if you have a variable or a vector, which is actually numbers. So this is again very well possible, right? So I'm saying that the number 1 resides at the position number 1, or the number 4 resides at the position number 2. Are we able to resonate with what I'm trying to tell everyone over here?
Yes,
Guys?
sir.
Yes, sir.
Great. So now the thing is, once I know the position or the index of the variable name sitting over here, how do I call that guy? What do I mean by saying that is, if I know that, let's say this number 10,097 resides at some position X, for example. Now, how do I call this number? How do I exactly extract this number? So for that, everyone, for extraction, again, keep it as a thumb rule. Whenever I assign a parenthesis, wherever I assign a parenthesis with a keyword, it becomes a everyone, it becomes a
function.
absolutely, it becomes a function. It becomes a function. Great, good. Whenever I want to extract, I will use square brackets. When I say extract, it means that I want to go inside this star and get something out of this star now. So when I write this star square brackets, I am going inside this star now. Now I have to tell R what exactly do I want to extract from it. If at all, let's say you want to extract the variable name f or the distribution name f, it is residing at the position number 3. You will give the index or the position as 3 now. So how do you read this is, go to this star or go inside this star and extract whoever is sitting at position number 3. Now if I run this much, it says this star not found. Obviously a rookie error. Just run this star and again run this star 3. And now you see that f value coming up over here. Is that making sense, everyone? I don't know if it was Bhavani. Bhavani, are you is that answering your question what you had? So in the world of those data points, how exactly do you keep on extracting all of those one small data points?
So it's not one, it's undiscussed question. So I
Sorry,
understood.
my bad. Whoever's question it was, sorry, I'm so sorry. Are
No, no.
you clear? I think if it was Anushka, are you clear?
Yes.
I hope that makes sense.
Sir, we can extract value of, like, we have, it is a one-dimensional data. What if the data is two-dimensional or there are multiple data points? How would we
Yes,
do that?
yes, absolutely. That's a fair doubt. Before I answer that question, have you guys seen the square brackets anytime before this when I wrote it down over here?
No, sir.
Okay. If you remember, or if I just
Please
go back
see the
to my
data point.
screen, if you see, R was trying to show you the square brackets right from the very first day of our lecture. Do you remember the very first program I wrote? I wrote 1 plus 1. When I executed that, R gave me an output of 2, but it also gave me something in square bracket as 1. Now I hope you appreciate it was nothing but the index. So it says that the second number or the 2 number is sitting at the very first position. Guys, are we able to resonate over here?
Yes, it's very clear.
Similarly,
Yes, sir.
if you see the environment, it says this star 1:4, saying that it's a character vector going from 1, 2, 3, basically having 4 elements, right? Now, just to further add, how do I do it in a multi-dimensional or a array or a 2D array or a matrix? You see this comma over here, everyone?
Yes,
Yes,
sir.
sir.
So 1 and 2, can I say it's the first column?
Yeah.
You see, there are 2 commas now, or sorry, there's one comma here now. So if I write matrix and I want to extract something out of matrix, square brackets. Now since it's a 2-dimensional thing, I will have to give information about 2 axes, one on the left, one on the right of the comma. If you remember, or if you can recall, the right side of the comma was nothing but for the columns, right? So if you want the very first column of the matrix, you will write 1. If you keep the left side of the comma blank, it means everything of the first column and all rows. So if I just run the matrix first, then everything of the first column, can you see that these 2 elements are exactly the same? It will return me back 1, 2, or obviously 1 and 2 rather. You see it has 1 and 2. If you want the very first row and the very first column of the cell, you will write 1, 1. It's that exact same definition what you guys used to write in your school books. So 1, 1 gives me an answer of 1. If you want the first row and all column values, you leave that comma blank altogether. And now you have 1, 3, 5. You have 1, 3, 5. If you see exactly same definition, what R was trying to tell you right from the beginning in terms of the outputs. Is this making sense, every one of us over here?
Yes, sir.
Yeah,
Yes, sir.
So this is how you index for multi-dimensional as well. Right? Can I ask you a question on the same? Everyone?
Yes, sir.
Okay, fair, great, thank you. So can you quickly solve these 2 questions for me? And we'll stop for the day. So you can take 2 minutes. At 39, I'll start solving. And I think I should take less than maybe 10 seconds to solve it now. And then we are good to go. In the meanwhile, I can take the attendance. I think that's good utilization of our time. Okay, we started at 12 o'clock. Right. We had 2 lectures. 1. Okay. We did data structures. Great. Bhavani is present. Hansraj, quickly present, absent. Okay, absent. Rishitej.
Hansraj is
Yes,
here.
sir. Present, sir.
No, who's present? Hansraj or Rishitej?
Hansraj.
Hansraj present. Okay, Rishitej absent. Ashok, I think he is there.
Yeah, present.
Kaustubh is there. Riya is there. Harnil.
Absent.
Okay, Yash.
Absent.
Okay, Anushka is there. Ali is there. Oath, I'm not sure.
Absent.
Absent. Okay, Ansh.
Absent.
Abhar.
I'm there, sir.
Okay, great. Thank you. Tom was there. Ashish.
Absent.
Okay, Dikshita. I'm assuming absent. Saumil. Absent. Anto. Absent. Fatimatul. Absent. Manav.
Present.
Okay, thank you. हाँ 2 मिनट दीजिए ना, हो गया मेरा लेक्चर. All right then. Attendance marked. Let's quickly solve it. Anyone of you guys were able to get through this question? Okay, no worries. I think let's not extend it. I'll quickly help you with guys. Iris data set, hence the term iris. It's a 2D structure because it's a data frame. First 2 columns, right? So how do you write 2 indexes all in one shot? First 2 means 1 and 2, right? So either you can write 1, 2, but again, 2 vectors being supplied together, 2 elements being supplied together, a vector. So either you can write something like this, or you can write something like this. Absolutely fine. First 3 rows, so 1:3. This is the answer for the first one. For the second one, empty cars. Again, an inbuilt data set. If you just view empty cars, right, a good data frame altogether here. It says extract third, fifth, and 15th row. So I will just push this down now. So third, again, rows I want third. So C 3, 5, 15, and 2, 4. 2, 4. Good to go. If I just execute this much, you have the required set of data points over here. And same goes for iris as well. See if this makes sense. Or it was easy to understand and good to go. Everyone?
Yeah, sure. Understood.
Yes,
Understood?
sir. Understood.
Great then. Let's close here for the day, guys. Just go refresh it quickly. Tomorrow we'll connect back. Tomorrow we'll start with conditional statements and logical operators. So from tomorrow, I think we'll start to have good number of questions and some complex questions coming around the game. Right? Chalo. So just go revise and come refresh before we meet tomorrow at 8 a.m. Any
Thank you.
doubts, obviously happy to take. Otherwise, we are good to go. People can leave. If you have any questions, any doubts, anything you want to talk, I am here. Otherwise, we are good to go for the day.
Sir, all these data frames